Hello and welcome back to Geometry. We are in Chapter 11, Section 3. We're talking about areas of polygons. I know you've been enjoying circles a whole lot, but we can't stay on circles forever. So, here we have a rhombus and a kite. Alright, so to find the area of this, first thing we're going to do is we're going to split this up into two triangles. Now recall that the diagonals in both a rhombus and a kite intersect at a 90-degree angle. Okay, which means I can use, and the diagonals bisect one of, in the rhombus, the diagonals bisect each other. In the kite, one of the diagonals bisects the other. Alright, so here we know that this segment right here is half of D. Right, so if we want to take this triangle, we could say that the area of that triangle, I'll do that in red up here for you, area of that triangle is 1/2 the base, which the base is D1, times the height, and the height is just this here, which is half of D2, right? So times half of D2. Okay, and then we could simplify that and say, well, that's 1/4 D1 times D2. Okay, but that's just this triangle up top. Alright, since this is bisected and this part of it is equal, we have 2 times this triangle. So if we take this, that's just that part. But if we take this segment here and we say 1/4 D1 times D2 to get the entire rhombus, we'd have to take that one triangle, which is this one, times 2. And 1/4 times 2 is 1/2. So then I end up with the area of a rhombus is 1/2 D1 times, I should say D2. 1/2 D1 times D2. Okay, there you go. Notice that the same thing works over here. 1/2 of the diagonal, this is 1/2, right there, 1/2 of D2. Okay, so again I could use area as 1/2 D1 times 1/2 of D2. Half base times height. And then since we have that triangle twice, we could do 2 times. So this works for a rhombus as well as a kite. Alright. Ignore this arrow here. So this is not pointing to that arrow. Alright, here we go. Find the area of each rhombus. Okay, so it's 1/2. Area equals 1/2 D1 times D2. Diagonal 1 times diagonal 2. And so that's 1/2 of 6 times 8. 1/2 of 6 is 3. 3 times 8 is 24. Alright, and that's meters squared. Here we go. Area is 1/2 of 10 times 7. 1/2 of 10 is 5 times 7 is 35. Again, centimeters squared. So that's easy peasy. Now if we want to look at regular polygons, finding angle measures in regular polygons. Well, first we have to look at a regular polygon. That's not the one I was wanting to work with. Here we go. Alright. So, in a regular polygon, every side is the same length. Every angle measure is the same. So this angle is the same as this one, which is the same as this, and so on. Alright. In that, we call the distance from the center to the side. Now remember, that has to be at a right angle because the distance from point to a line has to be at a right angle. Has to be perpendicular. That's called the apothem. So PQ is called the apothem. We usually use the letter A for that. Okay, and then PN is the radius of the circle in which this regular polygon is inscribed in. And so MPN is the central angle. To find the central angle, I would take 360 and divide it by however many sides. Let's put that down there. Divide that by however many sides the polygon has. So in this case, in this example, I would take 360 and say, okay, 1, 2, 3, 4, 5, 6. So it's a hexagon, divide by 6. So the central angle here is 60 degrees in this case, because I take 360 and divide it by how many sides it has. All right. Now we want to find, let's shrink that, find in this regular pentagon, very important that this is regular pentagon, okay, is inscribed in the circle. We want to find these measures. Measure of angle AFB. AFB. So that's the central angle, which means we take 360 and divide it by how many sides this had. It's a pentagon, so it has 5 sides. So that is 72 degrees. Okay, then FG, we want to find AFG, since FG bisects AFB, then AFG is 1/2 of measure of angle AFB. So that's 1/2 of 72, and that is 36 degrees. Okay, so this right here is 36. All right, and then we want to find GAF, G-A-F. So now we want to find this measure down here. All right, that measure, well, we've already found this one up here. We know that that one's 90, so we can use the triangle sum. Say 180 minus the 90 gives us 90, and then minus the 36, and then we're left with 54 degrees. So that's one way you could do that, since we've already found this. Otherwise, you could look at it and say, well, this side of it is the radius, and this side is the radius, which means this is an isosceles triangle. So you could also say the base angles are the same. So you could find 180, subtract the 72, and then split those in half. All right, finding areas of regular polygons. If you split up a polygon, you split it up into triangles, always going from the center to the vertices, and then the apothem would be the height. So we can say the area would be 1/2 base. The base is the side length, 1/2 base being the side length times the apothem. That would be the area of one of these triangles. Okay. Now, if I want to find the area of the entire shape, I'd have to see how many of these triangles are there. There's 1, 2, 3, 4, 5, 6. Okay, so that's just as many as we have side length. So I would have to multiply this one by 6. But to generalize that, I have to multiply it by the number of sides. Okay, so 1/2 base times height, 1/2 side times apothem, times the number of sides. Now, we can take the side times the number of sides also to mean the perimeter. So we could rewrite this also as saying, instead of saying side times the number of sides, we know that that's also the perimeter. So I could rewrite the area formula also like this: 1/2 apothem times perimeter. This is the perimeter. Okay, so there's 2 formulas for you. You can use either one depending on what you know or what you're looking for. In this case, we have a nonagon inscribed in a circle. Non comes from 9. It means 9. and it has a radius of 4 units. Find the area of the nonagon. Alright, so we know this is 4. Let's redraw this so we have a triangle. It's a little bit easier to imagine what we're doing here. Okay, so here's our right angle. Okay, this is 4. Here's point L. This is point M. This is J, and this is K. Okay. First step is we're going to use this information to give us an angle. Alright? Since it's a nonagon, we can say the central angle, okay, angle L, is 360 divided by 9. Alright? So the central angle is 40 degrees. And that makes half of this, that makes MLK. The measure of MLK, or KLM, is half of 40. So, half of 40, which is 20. Alright, so we have this measure here. That's 20 degrees. Now, we can find this measure if we want, but we're going to use sine and cosine to help us find the other sides. So if we, remember SOHCAHTOA, sine, opposite, hypotenuse. Okay, so we have the right angle here. This is the angle that we know. So sine 20 is going to be opposite to hypotenuse. So sine 20 is opposite, that's MK. So that's how we can find this measure right here, to hypotenuse, which is KL or LK, which is 4. Alright, now if I want to find MK, I'm going to multiply each side by 4. Multiply by 4, these cancel out, and then I get sine 20 is equal to 4 times sine 20 is equal to MK. Okay, and then I can find LM by doing adjacent, so cosine. Cosine 20 degrees is equal to adjacent to hypotenuse, so LM over 4. Again, multiply each side by 4, and then we get 4 cosine 20 is LM. Alright, now we have the height, and we have the base. Okay, now in order to find the whole thing, I need 2 times MK to get the base. So we have the area is 1/2 times the side, which is 2 times MK. Okay, that's JK, is 2 times MK, times the apothem, which is this right here, which is LM. So LM times the number of sides, so times 9. And we know that MK, so 1/2 times 2, 1/2 times 2, and then MK is 4 sine 20 times 4 cosine 20 times 9. And we can type all that in, and that gives us approximately 46.3 units squared. Alright, and finally I'll just walk you through this problem really quickly. If you want to find the area, first you need the perimeter. That's 8 times the 15. Then we want to find the apothem. So half of the 15 is 7.5. Use a Pythagorean theorem. Finds me the apothem. And then once I know the apothem, right, Pythagorean theorem, using the 7.5 and the 19.6, then I can find a half apothem times perimeter, and that gives me the area. Okay, so let that sink in, read through this one, write down the example, and there you have it. Lots of fun, ladies and gentlemen. Check in again next time for another fun lesson.